And welcome everybody to another Saturday discussion. This week we actually have someone that I've learned a lot from already, Kenneth Love, who is an instructor at Team Treehouse. And if you don't know Team...
It's just Treehouse.
Well, Treehouse...
Sadly, we don't have that domain yet.
Yeah, so Treehouse, which can be found at teamtreehouse.com.
Yeah, it's fun.
And I'll do a selfish plug. I'm a student there. I enjoy it. They have everything from Python, Ruby, JavaScript, WordPress. I think I saw there a few times, HTML, CSS.
Mm-hmm.
Some e-commerce stuff too. That was interesting. Like, you guys have everything.
Yeah, we've got iOS, both Swift and Objective-C. We've got Android. We've got game development with Unity now. We got Maya stuff. C# is coming. It's like a couple of months away. God, I don't know. We got all sorts of stuff.
Yeah, that's insane. So,
yeah.
But today is not about any of that stuff. Well, it's about the Python stuff.
Because that stuff's all crap.
See, you're allowed to say that, but I'm not. I get yelled at when I say things like that. But without further ado, I'm going to pass it over to Kenneth, who's going to talk about list comprehensions, or Python comprehensions. I shouldn't say just lists, and generators. So there you go.
Yeah, we'll talk about all of it. So I figured, since I don't know what everyone's comfort level is, that we would just start easy. So, for instance, a for loop. You know what a for loop is, right? So a for loop is a loop that lets us do stuff. So we'll say for letter in hello there. And when I run that, we get each of the letters. All right, so for loop, we just broke apart the string, we grabbed each letter out of it, and then we uppercase that letter. And the fun thing is print puts it all on a new line, so you get the big long thing. So for loops are great because they let us loop over things that are iterable. And by iterable, I mean it has more than one thing in it. The only thing I can think of off the top of my head that doesn't have more than one thing in it would be Booleans and numbers, integers and floats. Strings have more than one thing, lists have more than one thing, and so on. So for loops let us loop over things that are iterable, but for loops are always at least 2 lines, right? There's always a line that starts with for whatever, and then there's the line that actually happens inside the for loop. It's not always that fun, so we're going to fix that in a minute. So now let's talk about lists. So lists are a way to hold more than one thing in a single object. So we can, and it could be bright copper kettles, and I forget what the other one stuff was, warm woolen mittens. So now we have 2 things inside of one object, and I can do like one, and that's going to give me the item that's at the 1 index. So this is at 0, this is at 1. Cool thing about lists is that we can do and then we'll get our printing here. So we looped over each thing. And then using this end just puts it on the same line instead of having multiple lines. Lots of times we don't want to type out a whole list, though. So we can also... Actually, it's not going to do that. Yeah. Now we have nums. And if we were to print nums, there's our numbers. Range gives us it generates a list. Pay attention to that word generate. We're going to come back to that in a minute. Another,
when you're typing, your mechanical keyboard is muting you.
So, oh, all right. I will.
The best to talk then type.
Can I reach? Oh, I can't. I'll just use my non-mechanical keyboard. another way to make let's see, let's do grab all of that. Whoa, no, what did I do? This is what happens when you try and not type, but still make cool stuff. All right. There we go. So now we have fave things here, and we'll do fave list equals fave things dot split. And we've got that. Let me make sure that my notifications don't pop up. So we can use split to turn a string into a list, and by default it splits on spaces and tabs and new lines and things like that. The reason I'm going over these is just to show some different ways we can get lists, so that when we start playing with list comprehensions, it kind of all works together and it's fun. All right, so one more thing about lists is, actually we already did it, looking at my notes, sorry about that, is that we can loop over lists, which we knew because we did this thing up here, right? All right, so let's talk about comprehensions real quick. We're going to combine these two things. So we have a for loop and we have a list, and lists are created by using the square brackets. So if we were going to do a list comprehension, we smash those two things together. It's the whole peanut butter and chocolate thing. So just to keep going, let's not even worry with that. Let's go back to numbers. So let's do squares. And we've got, okay, let's do a for loop. Squares equals this. For num in range, square num to the second power. Print squares. Okay, so we have all these numbers between 0 and 10, so it's the same list as up here, 0, 1 through 9. And then we're going to square each number. So the square of 0 obviously is 0, the square of 1 obviously is 1, but then we get 4, 9, 16, 25, and so on. So this is kind of cool, but it took us 3 lines to do a very small amount of work. So cool, but whatever. So let's do it better. So we're going to do square comp. We're going to say this is a list. So like I said, we're going to smash these things together, peanut butter and chocolate. So what we want to do is we want to do this num squared, right? So let's do num times 2. And now let's do our for loop for num in range 10. So this code here and this code here are exactly the same thing. All I'm missing is a colon and creating the variable before and calling dot append. And if we print, then we see that we get the exact same thing. So this is what we mean by a list comprehension. It takes a for loop and basically gives us a list from it. And we're doing a little bit of mappy stuff here with applying a function to it, but that's okay. So before I go any farther, any questions about list comprehensions?
I was actually going to ask that, like you mentioned using a map, and here you're kind of just doing, like you said, you're doing something really simple here, num squared for num in range. Would there ever be a time where you're like, don't use this comprehension? Maybe that's something we might cover a little later, or if you're moving on.
Don't use this comprehension?
Like the times where you wouldn't want to use a list comprehension, but still get the same result, where maybe the 4 would be better.
Yeah, I mean, so let's make this one a little bit more complex. All right. I love IPython notebook, but at the same time, it's a little bit. So num1 plus num2. Oh God, where's he going to get num2 from? For num2, actually, we'll make this one num2. Num1 and 5, 12. So that gives us this. So what are we doing here? We have 2 for loops. And so it runs through, if I remember correctly, it runs through the outside one first and the inside one second. So we're getting the number 6, and then we're adding it to 0, and then we're squaring it. And that gives us 36, because 6 plus 0 squared is 36. And then we get 7, and we add that to 0. So if you look, let's see, where would it be? It's probably right here. This is our list of 6 through 12, plus 0 and then squared. And then here's our 6 through 12 plus 1 squared, and plus 2, and plus 3, and plus 4. So this is still fairly readable. It's only a single line. It's not too bad. But if you start getting longer functions that you're applying, maybe you're adding an if onto the end, maybe you've got a third for loop, list comprehensions start to get fairly unreadable. And this is where I'd say that you bring in map or filter or something like that to make it a little bit more modular and a little bit more easy to read. Now, it is Python, so anytime that you have a container, you can stick in, returns, and Python's not going to care. Like that right there is going to work just fine, as you can see. And yeah, that's more readable, but you still have to keep following that logic that, okay, there's a for loop, and then there's a for loop, and then there's this thing, and then there's that thing. So all the comprehensions we're going to talk about work best if they fit onto a single line and they don't have a lot of conditions to them. So just keep things simple. It's that whole, keep it simple, stupid thing. That is really what you got to do in programming. Okay.
Awesome.
So that's list comprehensions. They're, they make lists. One thing that you'll see a lot of people doing, and that's really not a great idea, is you'll have some function. And they just want to call that function on X as many times as it's in Y. And lots of times you'll see it as like range 10. They want to call this function 10 times. Don't do that, because it doesn't communicate what you're doing, right? It looks like you're creating a list, but really you're just calling a function 10 times. Use a for loop.
I definitely think that I'm a victim of that.
Yeah, a lot of people do this. And it's like, yeah, it works, but don't do that. And I mean, you'll see somewhere like they don't even use the X. They're not even using X. X is thrown away. They're just calling a function 10 times. And it's like, yeah, you achieved your goal and you only did one line, but I don't know. I can't look at this and go, oh, that's what they're doing. I look at this and go, why didn't they put that into a variable? Where's the variable over here? So don't do that. We're going to delete that part. Nobody should be doing that. Okay, so that's lists. Dictionaries, which I have become famous for being able to enunciate the T on the end of when I say dict all the time, so that it never comes out badly on tape. Dictionaries are like lists, but they let us put a name to a value. So if we have a list, and we've got 1, 5, 18. I love those numbers. There's no way to say, hey, give me the 1 out of here, unless I know where it is in the list. I have to know it's at index 0 or index 5 or index 10 or whatever. So that's not super handy. But a dictionary lets me have a key that goes to my value. So I can be like, age is 1, and fave color is yellow. That makes no sense as nums. We'll say, and maybe And so that gives me this dictionary. It doesn't always come out like people think. Oh, haha. I forget that I have to quote my keys. There we go. So that'll print out, and there's my dictionary. But if I loop through it, dictionaries are kind of weird that way. Wow. All I get's the keys. So what a dictionary actually does is it's a construct that holds onto a tuple of keys, not a couple, but a tuple. And so you have this tuple of keys that's kind of randomly ordered, and it finds the key and it knows what that key points to, and then it goes and finds the value. So your dictionary never isn't really holding on to the value the whole time. It's somewhere off in memory, but it doesn't like come along with the dictionary. What comes along with the dictionary is the key, which is why when I loop through it, I only get the keys. I don't get the items. So let's talk about how to fix that. There is a wonderful function called, or method called items. So if I was to do print, then we get this dict items construct, which is a list that's not a list. And here you can see the list part. And inside of that is a set of pairs, which is a tuple with 2 items in it. I picked that up from Haskell, and I love that name. The first one's the key. The second one's the value. Always. What's cool is you can actually make a dictionary this way, too. So if we wanted to do ages, and we'll use the dict constructor. And then here we can do ages. As a list of tuples, so the exact opposite of this, and it'll make an actual dict. So if we loop through a dictionary, we only get the keys. We can make a dictionary by sending in pairs. Can you guess how we make a dictionary comprehension? By sending in pairs. So it works just like a list comprehension does. Let's get a couple of random things here. So we'll say red, yellow, blue, green, and import random. Nums equals random.rand int 10 through 50 for color. Okay. So right now, if we look at this, we've generated some random numbers and we have some colors. I want to make a dictionary out of those. I want to say that those colors point to those numbers. Maybe it's a hue or something like that. So I can do color num for color num in zip colors nums. There we go. So if you don't know what zip does, zip lets you send in 2 or more iterables, so lists, tuples, dictionaries, whatever, and it'll give you the first item from each of them as a tuple. It'll give you the second item from each of them as a tuple, and the third item from each of them, and the fourth item, and fifth item, and so on. So you're compressing 2 or more iterables by taking 1 item from each at a time. So what we're doing here is we're setting the color as the key. We're setting the num as the value. We're getting the color and the num from this zip function, which gives us the first color and the first number, which our numbers are going to be different because we're using random. But notice we get red and it gets 1. We get blue and it gets 1. We get green and it gets 1. And the reason these keys are out of order is because dictionaries don't have a set order to their keys. Usually it seems to come out kind of sort of alphabetical, but it's not at all guaranteed. You can't ever worry about the order that things are in a dictionary. Okay, dictionary comprehensions. Not as useful as list comprehensions. You will not use them nearly as often, but it's still good to know that they're there. Any questions about dictionaries before we go to something I really like, sets?
No, I think you're good. I was looking at
Still getting a little muted?
Yeah, just a little bit.
All right.
I wanted to look at zip more, mostly because I just, like you've said, it's one of those things that I don't think I've ever actually used it in like production code. I'm just really trying to think of like good times. I mean, just like this one, you're kind of right, but I think the inconsistency of the dictionary order kind of limits you on what you can do with that. I mean, unless you're going to use like an ordered dict, which is kind of.
There we go. Let's do that. So if I print a list of a zip, because a zip is its own kind of object. A zip is a generator object, which we're going to get to in a bit. So you have to turn it into something else. You have to consume it and make it something that you can look into. So we turn it into a list. So when we get a list of a zip of colors and nums, colors is ordered. So we're always going to get red first, right? We're always going to get yellow second. We're always going to get blue third. We're always going to get green last. So if you look here at where we're printing the list of the zip, we get red first, we get yellow second, blue, and then green. And then we get whatever random number we have to have generated from nums. So because of that, and actually we're getting the same numbers every time because we created nums once. So because of that, you can see here we're getting the pair, right? So if we were to look at nums, here it is, there's nums. If we were to look at nums before, we're going to get 31 first, and we're going to get red first. So we get red and 31. 30 is second, yellow is second, so we get yellow and 30. Zip is amazingly useful. Think about if you're generating a CSV or you're consuming a CSV, and you have a row of headers, right? So you have an ID, a name, employment date, status number, whatever, right? You've got all these columns in your CSV. So your first row is usually your header row. So you're going to take that out and you're going to call it headers, and it's a list, and you're just going to hold on to this list, or it's a tuple, or it's whatever. And you're going to hold on to this. And then for each row that you're going down, you want to make a dictionary out of this. So you do a zip of the header row and the row you're currently on. And now you have this pair of the header and the value. So you can immediately turn those into dictionaries. And then you combine a list comp and a dictionary comp, and boom, now you've got a list full of dictionaries of all your employees in your CSV. Yeah, you break that problem down real fast. The good thing is there's libraries out there that'll do this for you already, so you don't have to do it yourself. But if you really want to, you can. And that becomes a really handy way. Sorry, go on.
I think that's probably why I haven't used Zip, is because I think a lot of the tools that I've probably used in the past include Zip, some type of Zip function in them. So I think I like that idea of using like to manipulate a CSV file, or to maybe to manipulate a spreadsheet if you're doing something with spreadsheets. Mm-hmm. Like I said, it's one of those things where I haven't gotten much into it just because there are modules out there that do it, but my motto is always know what the module is doing. So this kind of, rules that, that brings this to light. I can kind of explain now what this module is doing probably a little more clearly than I could before.
There's also a thing too where you have to weigh the benefits of bringing in a library or a module versus just writing a quick little solution in raw Python. Lots of times it's not worth it to bring in that extra library. I mean, if you're only parsing, yeah, we have a CSV module built in, so that one's kind of moot. But maybe you're parsing, it's not a CSV, it's not a JSON file, it's some weird, it's some format that Python doesn't understand, but you can get to it in that same kind of manner, right? Like you can read the file and you can parse things out. Finding a module that somebody else wrote for manipulating that type of data, installing it, using it in your project, making sure it works, all that kind of stuff, takes a bit of time. But if you can go, yeah, I mean, I can open this file, I can break it down by lines, and I can combine those using zip and, you know, maybe a dictionary, or zip and a list, or zip and whatever, you've probably saved yourself a lot of time. So finding these handy little tools that exist in Python, like zip or chain, is amazingly handy. And it goes a long way into making it to where Python is your go-to language to just solve any little problem you come up with, because you know all these handy little tools. You've got a large toolbox full of stuff. So yeah, zip has limited use, but it's really freaking handy. Especially, I mean, you know, if you add more stuff into this, like I can add as many things into there as I want, right? As many iterables as I add, zip knows how to handle, and it just gives me the first thing from each one of them. So maybe that true, false, true, true is whether or not I like this color, or whether or not we've used it already, or something like that. And I can keep adding iterables to zip. So, you know, then I can go in and add get letters from poop. So yeah, zip becomes really, really handy as you're dealing with more iterables and more just stuff.
I didn't
And
think
zip's a
about
generator.
that. So that's
Yeah,
awesome.
zip's a generator, so you're not actually holding on to all this data at once. You're only holding on to the thing that you're currently on. So if you know that you've got 50 iterables that you need to process one item at a time, and you want to use zip to do that, zip's not going to add a lot of overhead to your workflow. You're not building up a ton of memory, which is really good and really important.
Oh.
And we'll talk more about that later. I keep bringing that up. But yeah, we're going to get to generators and yield in a bit. So anyway, that's dictionaries and zip, apparently. Let's talk about sets. You might remember sets from algebra class, or I guess really it's more of like a calculus class, but still. So let me make a quick set. And I'm just going to do a list of the word Oklahoma, because I like this one. So what a set is a set. That's not a set. That's a set. A set is a non-ordered iterable. So it's like a list. It's only a single layer deep. There's no key and value, but it's non-ordered. You don't know what order things are going to come out. And each thing is in the set only once. Okay, so sets are infinite. They can contain, I mean, you know, within constraints, an infinite amount of stuff. But sets are huge. Sets contain a huge amount of stuff. Sets are unique. Where that becomes handy, let's rename this one to Oklahoma. Let's make another set. For this set, we'll use okay, so two sets, some similar items in them. Where sets become really handy is being able to do this. So there are all the letters that are in Oregon and Oklahoma, but each one's only in there once. So I did a union. I combined the two sets. Okay, so that's cool. That's great. Everything's unique. I don't have to worry about it. What about difference? So there are the letters that are in Oregon that are not in Oklahoma. So only the O gets knocked out. This one isn't going to be more interesting either way around, because those two are pretty much unique already. there's the opposite of that. And then there is also intersection, which is what they have in common. So sets let me have things that are in both things, and I can see how these sets come together. The reason I bring up sets is A, most people don't know about them and don't use them nearly enough. And B, sets have comprehensions. So just like if I was doing a dictionary comprehension where I use the curly bracket, the curly brace, I do the same thing for a set comprehension. So whatever. That's good enough. I don't have the word supercalifragic in my head. So there we go. We can build up a set of that with a for loop, just using the curly braces on the outside. So it's nice to be able to build a set like this because I know that that set's unique. I know I don't have multiple copies of the same letter. I don't have anything like that. Where you'll see people use sets a lot is in, they'll do this. They'll have nums equals A to A lists. They don't care about the order of the numbers, but they care about the fact that they are unique. So they'll toss it into a set to make it unique and then toss it back into a list because they want to work with a list and not a set. Don't do that. I mean, do it. It's fine. That's the only way to make a list unique easily. But that's just a waste of a set. Learn how to use sets. Sets are awesome. Yeah, you won't use set comprehensions a huge amount except for basically making things that are unique, but they're really handy for that. And I think this right here, if you can do it, is much nicer than this right here.
I was going to say that sets just seem like they're going to become one of my new favorite tools, especially since I do a lot of stuff with web scraping. So anytime I can, and I mean the big thing with that is I don't need to have the same links. I don't need to have the same information multiple times. So I've always done like this, like iterate through it, append it to a list, and if it's not already in the list, then append it to the list. And it's just like, oh, that it didn't seem. It was like, it's one of those things where it's like you do that because it's the only way you know how. But now looking at like as a set, this just seems like it would be way more. It seems like it would be better. I think the one problem that I would have with it is, like you said, it's not ordered. So I think that's where you're going to have like that headache for me at least. But I do see, just playing around with, Oregon, looking at differences, looking at union, things like that, and looking at those sets, it seemed very, very valuable.
Okay. I could have sworn that was possible. Anyway, I guess it's not. That's our the unordered part kind of sucks, but it's not that big of a deal. I mean, effectively, really, if you look at it, dictionary keys are a set, right? Because they're unique and they're unordered. I say they're a tuple because I do believe that's what they actually are stored as in memory, but they're effectively a set. So yeah, sets are amazingly handy. And then being able to do the unions, the differences. There's a couple others. There's what is it? I think it's inclusive intersection, or I don't know. Go look at sets. They have great documentation. And they're really, really handy. You'll also find them in places that you might not think about. If you think about whenever we talk about pulling records from a database in like Django, we call it a query set. What's that last word there? Set. Ideally, they're unique. There are ways to make queries that give you non-unique entities, but most of the time you get unique items from inside that. So yeah, sets are really handy. And a lot of people, like, I'm surprised at how many Python developers don't know about sets and don't use them way more often. But they're great. So those are the three kinds of comprehensions that we have in Python. We have list comprehensions, we have dictionary comprehensions, and we have set comprehensions. Now we can't do string comprehensions because strings are immutable. We can't add things onto a string. And we can't do number comprehensions because that's called adding. And we can't do tuple or tuple comprehensions because, again, they're immutable. We can't change them once they're created. But this is where the fun thing comes in. We're going to skip yield from here for a second, and we're going to look down here at generator methods, or generator, what are they called? They're not generator methods. They're generator statements. Generator statements. That's it. Okay, so let's do a large range here. Large nums equals a list of a range from 1 to 10, 100,000. Okay, so we have large nums. And large nums is a lot of stuff, right? That's 100,000 numbers, give or take one. 100,000 isn't going to bother us, right? We can hold on to 100,000 numbers in memory. That's not that crazy. But maybe we have 1 million, maybe we have 10 million, maybe we have 100 million. And we don't want to go through all of these at once. Or maybe we need to do an expensive calculation on them, right? Maybe we want to do, like, for num in large, you know, we're going to do like num to the power of 50. Again, that's still not that crazy for a computer, but we'll say that is, okay? That's potentially a lot of work. We don't want to do that for the entire list of 100,000 numbers. Screw it, let's make it 1 million numbers. Let's go big. We don't want to do that for a million numbers all at once. We don't want to hold on to all that because that's potentially a lot of stuff in memory and a lot of processing. So what do? So this is where we get to a generator statement. So output equals, or to num to the 50th power. And I got a generator object from a generator expression. That's it, generator expression. Ha! It looks like a tuple. It's not a tuple. It's a generator. So this is the one place where Python gets a little ambiguous. So what we have now, though, is we have this thing called output. And output has taken the first item in large nums, which is 1, and it has applied num to the power of 50, so 1 to the power of 50, to that number. And that's it. It held on to that, and it knows that it has 1 million numbers, and it knows that it's currently on number 1. That's all it has. So that's great. It knows it has 1 million numbers. It knows it's currently on number 1, and it knows what the value is for this first thing that I want, but it doesn't do anything else. So if I print, I get 1. If I do that again, I've got 2. If I do that again, I've got 3. So all that I've done here, and that's it. It only has those 3 numbers, and it's thrown away 1, 2, and 3. Well, it hasn't thrown them away. It knows they're there, but it no longer cares about the calculation on them. So by using generators, we can control how much memory we're dealing with at any given time. So I actually did a bad thing here, and I turned a range into a list, and a range is a generator itself. It actually only gives me the number that I'm currently on. But when I called list on it, I went through the entire range and got all of them. So I shouldn't have done that. If I'm a good developer, I don't do that. But most people end up doing these kinds of things. So that's what generators do, and that's what a generator expression looks like. It's just like a list comprehension or a dictionary comprehension or a set comprehension, but it uses parentheses instead of braces or brackets, and it stores everything as pointers, not computer science pointers, but pointers in memory. That's just saying, hey, this thing exists, and this thing exists, and this thing exists, and here's where I'm at. Right? I'm at number 20.
Can you be selective in your choice? So you've gone print output, next output, next output. Can you go give me the 30-second output?
Yeah, with 31 nexts.
Oh wow.
There's no indexing on a generator.
Okay.
Okay. So out of all the things I've gone over as far as comprehensions go, the only one that can be indexed is a list. Dictionaries can be indexed by a key, but it's not really an index, right? That's pulling it out by a key. Sets have no order, so sets cannot be indexed. You can't say, give me the 5th thing from this set, because that doesn't make sense. And you can't do that with a generator either, because that item doesn't exist yet.
Yeah.
Right?
Right.
So you basically have to call next like 45 times to get to the 46th item. And while that kind of sucks, it's also one of those things where if you're working with a generator, you probably don't want an indexed item. You're probably wanting to work your way through this list from beginning to end. I say list. Through this iterable from beginning to end. And you just don't want to hold that entire thing in memory. Right? I mean, like if I was to change to that suddenly uses up a huge amount of memory if I was to run this. I mean, nothing our computers can't handle these days. Like, we can do an amazing amount of stuff. But just because we can hold a huge amount of stuff in memory doesn't mean we need to hold a huge amount of stuff in memory. Memory management in Python is not a big deal, which I like. But at the same time, it also often leads to people writing very sloppy code, which is bad. People love to do sloppy stuff. So those are generator expressions. Does that make sense? How we've turned this list into something that's now not in memory.
Absolutely. And maybe this will be good for the post show, but is there any way that you could maybe create an index and not store all the values in memory?
Not that I know of. What you would probably want to do then, really, is you'd be like, I'm going to turn that into a function that I can call whenever I want. And then I'm going to have some way of knowing what the middle thing is in this collection. And then I'm going to call the function on that thing.
So maybe you have like an upper limit and a lower limit. Yeah, I think you'd have 2 limits, and then you basically check to see if the number supplied is in that range of those limits, and maybe throw an error if it's not within the limit.
Right. And then it becomes then like you're applying business logic. You're figuring out what the things are that you need to have in order to be able to accomplish the job you currently have to accomplish. You're not worried about optimizations, right? And that's fine. Most code should be written to accomplish a real goal. But sometimes that doesn't happen. Sometimes you need these nicer, more generic things like a comprehension that's just going to hold on to this stuff for me, and I'm going to get to it eventually. I mean, do not use this as a queue, but it's kind of a queue to where you're like, I know I've got all this stuff, and at some point I need to go through it.
You should probably
repeat, do not
use this as a queue.
Do not use this as a queue. This is not a queue. Python has a built-in data type called dequeue. Use dequeue for a queue, because this is not a queue.
I know someone heard you say that and was just like, wait, I could use it as a queue.
The fact that lists have pop and append does not make them queues. They are not queues. Use the right object. Oh God, use the right object. That said, for very small amounts of data, this works fine as a queue. Okay, but don't use it for one. Okay, so now let's talk about yield and yield from. So what we've done, we have this generator, right? We made this generator that goes through all these large numbers. I'm gonna bring this stuff back over. So put these over here. Oops. But I want this to not be. Okay, so we're back to that being an actual generator still. Okay, so yield has been around in Python for a while. I think it came out in like 2.3 2.5, 2.6, something like that. Oh yeah, you notice I'm on 3.5 even. Woo! It's been out like a week. Okay, so yield is a way for us to make a function into a generator. So let's talk about that for a second here. So we'll say def and to the power of 50, right? But we want this to be a generator. So we say yield. So what this does is, again, it just kind of holds on to that. It knows it's got this number. It knows it's got 50. But until I actually ask for this thing, it's not going to send me that. So that's great. That's cool. That's what I want. And then, and I don't know that I can come up with a meaningful example to these right away either. In Python 3.3, I think it was, and they backported this to 2.7, if I remember correctly. We got a new thing here, which is that we can do, let's see if I can remember how to use this correctly. Big power and yield. Yeah, I think it's something like that. So then if we get that generator object. And so what it's actually doing, let's see, let's do the, yeah, there we go. All right, we'll figure that out in a minute. I'm just going to explain this conceptually. I may or may not be able to provide an example. So what yield does is yield, instead of having return, it just knows that it's eventually going to calculate a number, and it's waiting for you to ask for that number, and then it'll give it to you. Okay? So yield gives us functions that act like generators, which is really, really handy when you have a function that does a huge amount of work. You don't want that amount of work to always happen. You want to be able to happen only when you tell it to, so you can use yield to go and grab something from it on demand. It can do the bunch of work, but it doesn't do it all at once, and it just doesn't when you ask for it. Yield from, which is a really nice thing that we got in, like I said, I think it was 3.3, you can do yields without having to do the work yourself. So if I go back to before 3.3, say I'm in 2.6, and I've got a function that takes a generator, and I know it's going to get a generator object, and I'm going to call next on that generator object. I have to call next myself on that generator object. I have to always call next. That kind of sucks. I have to do extra work. Yield from basically calls the next for me and figures out what the next thing should be and sends that back out. So yield from lets me work with generators without having to call the generator myself. I can go to the generator, say, hey, give me whatever your next thing is, and then I can give that back. So that's where yield and yield from. I didn't come up with great examples on these because these aren't part of comprehensions. These are more part of getting into a more memory management style of writing Python. But it works the same conceptually as the generator construct, the generator expression. So does that make sense for yield and yield from? You'll use them less often than you will everything else I've talked about today.
Yeah, it seems like the concept of them, the concept makes sense, but the implementation, like you said, is a little hazy. I honestly just can't think of when I would
So,
want
like,
a function to.
For example, something I did recently was, and I'm giving a talk about this next week. If any of you are in Portland and want to come see it, I built a Twitter bot, and what the Twitter bot does is it generates random haiku, and I mean like completely and utterly random haiku. But the process that goes and finds the words for me to build out a line can take a little while. And so I didn't want to necessarily be sitting and waiting on that the whole time. I'm not saying that I built this asynchronously or with coroutines, because I did not, but I should. But what I did was, since I know it takes a decent amount of computation, and I want to just be able to send it a bunch of stuff and then have it send me back things as it gets them and as I need them, I had it doing yield. So it just sends, like, I'm like, hey, give me a word that's 3 syllables, and it goes through all of its words and eventually finds me a 3-syllable word and sends that back. So using a yield on that made it a little bit nicer. I didn't have to deal with having quite as much stuff in memory or actively in memory. So I was able to kind of just relax a little in the code. It sounds like a horrible way of saying it, but yeah, I didn't have to do as much stress in the code. But yeah, like yield and yield from, those are more, you're going to be dealing with very large systems by the time you get to those, and you're going to know when you need to use them. Like, it's going to become like obvious. You're like, wow, this function is taking forever to send me back all this stuff. Let's try yield, and then it like shaves off a bunch of time. But generator expressions, those are way more useful.
Yeah, I think there was a talk. I can't remember if it was this past PyCon or one previous, where it was like, you need to start using generators. Use them more. Use them as much as you possibly can. Generators are your friend.
Yeah, you got to be really careful with talks like that, though, because I did it was 2 consecutive PyCons. One of them had stop writing classes, and the next one was write more classes, like a year apart. So yeah, you have to watch out with comments like that. But occasionally, yeah, it is a real thing.
I think it's always funny. You can tell what the last set of videos were based on the code that I produced afterwards.
Mm-hmm. Yeah, I mean, that's really common. You write something and you're like, oh man, this is so, or you hear something, you're like, oh, this is so cool, I gotta go use this thing, and then you immediately go try and start using it, and then all your code before that does not look that way. So yeah, I mean, that's comprehensions. They're not really big and scary. They're basically just a for loop smashed onto one line, and they give you back a list, a dictionary, or a set, or a generator. But yeah, those are, these generators are now everywhere in Python 3, which I love. Almost everything you call that comes out with a custom data type, usually that data type is a generator of some kind. Which means that Python under the hood is paying more attention to memory management, which means it should run faster and smaller.
Awesome.
Yeah. Did you want me to talk about map or filter?
Well, I was actually going to say we're going to wrap it up here. I think we're about to hit the hour mark, and I was going to say if people wanted to ask you more questions about comprehensions, or I guess map and filter, where could they find you?
So I mean, I'm on Twitter a lot. It's just Kenneth Love, all one word, just my name. Or I'm on the Slack channel for CodeNewbie. I'm usually in Python or Python Thursday, but you can ping me anywhere and I'll pop up. Or come to Treehouse. Like you said, it was teamtreehouse.com. I've got a lot of Python content on there. We have a very active community. There's lots of forum posts and everything. So yeah, if you need to learn or want to learn Python, it's a great spot to go and start learning it. I think. I'm biased.
Well, I'm not biased, and I can say that I've been using it for the past 5-6 months now, and absolutely, my Python game has ramped up exponentially. I've even gotten to the point now where I'm applying for Python developer jobs. So it's helped me out, and Treehouse has been the only online course resource that I've been using as of lately. So
cool. And then I'm gonna make this this Jupyter notebook. I'll make this available somewhere online if people want to play around with what I typed in.
Awesome. And I'm glad that you mentioned the Slack channel. We're actually going to continue the discussion offline, but if you would like to be a part of that, or if you have other questions, you can jump onto CodeNewbie.org, where we have our discourse, where if you have a question or that you're looking to get answered, you can get there. We also have a Slack channel that Kenneth is known as like the Python master on. So I can definitely say that Kenneth has helped me out, not just in Treehouse, but on forums, on everything. But the number one spot has always been the Slack channel. And he often tells me not to use, a jackhammer to put in like a floorboard nail.
Yeah, man, you gotta use those the right tool.
What can I say? I love regex. It's awesome. But and if you're also in another programming language, or if you're looking to learn another programming language, the CodeNewbie we have a community for almost every major language out there, from Swift to C, Ruby, of course Python, and JavaScript, all the different flavors of JavaScript. So I encourage you to get out and to work with CodeNewbie, and they're found on Twitter at CodeNewbies with an S, but everywhere else at just CodeNewbie. And I also want to plug in a new project that we're doing on Fridays for now, called Iron Coder. And this project is really cool, where you get to work with many different developers in many different languages, all trying to solve the same problem. And those are found Friday nights, I believe, at 6 Pacific time and 3 Eastern, or 8 Eastern. There you go. As well as many of the other projects that we have going on. And if you want to be a part of this community or be a part of the panel for next week or for any of the future weeks, be sure to jump into CodeNewbie on that Slack channel and join us, or find any of our content at #Saturday Discussion. So without further ado, say goodbye, Kenneth.
Goodbye.